您现在听到的是 Vincent Talk， 我是主理人 Vincent。本节目旨在探讨生成式 AI， 对话嘉宾包括博士、教授、创业公司等其他各个领域有代表性的人物。对话的主题包括技术、产业、科研等，希望能够为大家提供一个全方位的视角来了解生成式 AI。接下来给大家介绍的是我们的第一位嘉宾，他来自慕尼黑大学 Convis 组的2年级 PhD Stefan Baumann， 他会给大家介绍他的科研经历和体会，以及面试 Convis 组的有趣经历。So, Stefan, maybe make some introduction about yourself to the audience from China.
Yeah. So first of all, thank you for having me. It's a pleasure to be here, interviewed as the first person that you're interviewing here, as far as I'm gathering. I'm Stefan. I'm a PhD student at Comvis at Munich in Germany, and I'm supervised by Björn and Omar, and I'm working on large-scale generative models, primarily diffusion, primarily for vision applications, and I'm trying to understand how they work internally and how we can use these insights to control them, to derive insights from them, to use them to understand the world and other things like that.
Okay, thank you for the introduction. So maybe the second question. So since our lab is very famous for the generative models, so can you tell us how did you get into the world of generative deep learning?
Yeah. So that takes me back to 2017, 2018 when I started my bachelor's in electrical engineering. I had spent all of my school time trying to say, hey, I want to spend as much time as possible on tech stuff. Nothing else, everything else was boring. And I just wanted to spend more time on technology. I spent a lot of time programming, doing some computer vision stuff, some robotics stuff, etc. And then when I was confronted with only having to do that, nothing else basically, I thought it was not balanced enough for me anyways. So I thought I wanted to do only tech stuff, but it turns out I don't. And I got really interested in music through a friend who had a long history in music education and stuff like that. And he really got me interested in making music. I started to learn to play the piano. I started to learn to produce my own music. I started making up my own songs. And I figured out that I was not creative enough to come up with melodies myself, at least not creative enough in like the art sense. And I didn't have a background in machine learning back then, but that got me really interested in the question of whether we can just make the computer generate melodies for me. Because even random algorithms that you cannot come up with yourself are not that bad sometimes. So I started looking into the literature and found generative adversarial networks, GANs, and just tried to start and train them. I did it with the original GAN training code base that was implemented in Theano. It was horrible. It was not beginner friendly at all. But I managed to get some models to train, created my own data set, and then tried to build like LSTM variants of GANs to generate melodies for myself. But admittedly, it never really worked out well. I got some jumbled garbage, but mostly garbage.
Okay, so
but it got me inspired.
At that time, the most popular generative model is GAN.
Yeah.
So now you are doing a lot of topic about diffusion. So in your opinion, what's the main difference between them and how is the performance, for example, in that case, of audio?
So GANs, especially back then, were horrible.
Yeah.
They always collapsed to something, found some shortcut solution for the generator, for the discriminator, and they just never wanted to train. It was more wrestling with them than actually managing to get them to train. It has gotten better now, but I still think it's quite horrible to train them because it's just inherently unstable. It's not that fun. But at least it leads to very efficient models. On the other side, diffusion models are incredibly nice to train. You basically can't go wrong. They just work out of the box for the most part, as long as you have a sufficiently large model. But at the same time, as opposed to a GAN, where you get single-step sampling as a general feature with diffusion models out of the box, it just takes a long time to sample. You spend a lot of compute. And we don't just generate an image, but we encode a noisy image and then we decode it into a prediction of a clean image. And that's just inherently inefficient unless we go into distillation and other stuff like that.
Yeah.
So we have this amazing advantage of making these models nice to train and actually also making them scalable. GANs don't scale that well, but we get the drawback of a lot less efficiency, which, however, at least we have now somewhat figured out how to
So
address.
actually, that comes to another question. And so when you're applying for the PhD program in your lab, but by that time you're already quite familiar with diffusion model?
Yeah.
Okay. Then maybe you can describe how is your PhD application in your lab looks like, and what kind of interview you get with Björn, and how was the experience? Because actually many Chinese students are very interested into the apply for our PhD program. So maybe you can share something.
Are you interested in more general my PhD application experience or just for this lab?
And just for this lab.
Okay.
Yeah.
So just for this lab, my primary application originally had been through ALICE. So this is a European PhD and postdoc program where you can apply with one application to, I think it's still up to 10 professors. And of course, that's just a nice and convenient way to apply to a bunch of professors that are looking for PhD students. But also, for example, in the case of Björn Ommer, he had on his website a document where he said, hey, if you want to apply, and he didn't specify anything about ALICE, if you want to apply, please send a message with what your research interests are, what your background is, how everything relates, etc. So for Björn Ommer and also some other professors, I did that on top of the ALICE application and just said, hey, referring to my ALICE application, here is my research statement where I wrote, I think, 2 or 3 pages about what interests me in his specific area of expertise that he's doing research in, and proposed some own research directions. But just a bunch of stuff like that to really show that I'm interested, that I have some cool ideas, some cool thoughts. And yeah, then at some point, I think that was February, he invited me for an interview and we just had a talk online and it was really nice. And yeah, we didn't have like a formal interview in the classical sense of like a coding interview or something like that. We just discussed a bunch of these research ideas, what we're very excited about, etc. And then in the end, I also dropped by the lab because I happened to live a few hours nearby by train and just got to chat with a bunch of PhD students. Although I have to say, especially if you're viewing this from a perspective of somebody who might come from China, of course, this does not happen to be a requirement or something like that. Online interviews and everything, we do that as well regularly. But I just had the chance and took it to visit the lab in person and got to know the PhD students and figured out, hey, yeah, this is really a nice group that I want to join. And yeah, that basically was the most of the PhD interview process and how I ended up
then
here.
maybe another question I think most of the Chinese students they are very interested in is, in your opinion, what is the most important factor to get in? I mean, you may consider, I mean, in general, just for your PhD application.
Yeah.
Yeah.
So I feel like the main thing he is looking for is people who either already have a lot of experience or who have a lot of potential. I think he also invests in people who have potential, not just people who already have proven themselves.
Okay.
And you have to show that somehow. So either, of course, you already have a track record, and then it might be easier to get an interview and then get to know him, or you just somehow show that you're excited about this research area, that you have some exciting ideas. Of course, you don't have experience yet, so many of your thoughts will be stupid, but you can differentiate between people who are new to a field but excited and have creative ideas and people who just
I totally agree.
But
I mean, in your case, at least you need to have a chance to get the chance of the interview.
Yeah, but you can get there with the way you apply, right? So I had this long document with the research interests and stuff like that.
Okay.
And that was way before the interview.
Okay.
So I assume, I don't know what actually got me the interview in the end, what got me the PhD position in the end. But I assume that played a big role, that I had like a proper application where I showed that I'm interested in this field, that I'm curious about this, and that I have some creative ideas. And I think in the end, he also thinks a lot about how well people fit together in the lab.
Yeah, I think that's an important point.
That's of course something that only becomes relevant once you get interviewed, once he has an idea of how well you would fit in the lab, once you've interviewed with other people in the lab, and they have gotten to know you. Yeah, I think the initial one is just to show that you are excited about the topic and that you have potential, however one might show that. I think there's many different ways.
Okay. Okay, maybe let's go back to research. So can you sharing us what's your current research interest?
It's currently still quite broad for the most part.
But no audio anymore?
Not audio anymore, no.
Yeah.
I spent an internship doing diffusion models for audio for half a year, but that was enough for me. I personally ended up preferring computer vision over audio, for my research interest at least. Basically what I said earlier still applies. I'm trying to really figure out how large-scale generative models learn to generate the world, because when they generate such nice images that are so realistic nowadays, they have to have some amazing understanding of the world, right? And that has two aspects. First of all, it should give us probably some avenues to control them. If we figure out how they represent some stuff internally, we can use that to control them. And if you talk to creatives, if you talk to artists, they really are not happy with the level of control they get from these models. We as normal people, we are happy to type in the prompt, hey, an astronaut riding on a horse. And then we say, hey, this is a nice image of an astronaut riding on a horse. But the artist might say, well, the composition of this image is shit. And I want this to be this kind of horse. I want the horse to be in this pose. I want the astronaut to look here and stuff like that. And we're not there yet with this level of control.
Okay.
So getting control by understanding how they work internally is some really important aspect. And the other one is, of course, it's also kind of representation learning, right?
Yeah.
We don't really induce like specific representations in the model, but they have to somehow understand the world. And especially in diffusion models, as opposed to GANs, for example, they have an input for an image. They don't just output an image, they input an image and they process it further. So they're basically already feature extractors for images as well. And that's also quite exciting.
Yeah, I think nowadays the interplay between feature representation and the diffusion model is really popular.
Yeah.
So, I mean, for research, we need to submit. For submit, we cannot always just expect acceptance. So sometimes we'll come with some kind of rejection.
Yeah.
So can you sharing us your mindset how to deal with those kind of rejection?
Yeah, so of course we need to optimize in the end for our CVs and stuff like that we have some accepted top tier conference papers or just conference papers in general or journal papers or whatever else. There's just some expectations that are set externally.
Yeah.
But ignoring that, I think the main part one has to realize is that it's about doing cool research that one is excited about. It's not about getting that next conference paper published and that next conference paper published and that conference paper published and just maximizing that number. But it's also about, first of all, in the PhD, we are still students, right? We're still aiming to learn how to become a researcher. We're not a full researcher yet. We're doing a lot of research, but we're still learning.
Yeah.
So learning is already a big thing that is useful for us. And then the second thing is, once you have a good work, like a really good work, it's not that important that it gets accepted. Well, it's important for your CV in the end, maybe a little bit.
Yeah.
But we have tons of works that never got accepted to a major conference that still changed the field. We have a bunch of works that got accepted only after 5 rejections and then a resubmission. So I'm thinking about like Adam W. and stuff like that. Adam W., everybody uses it. I think it took 4 submissions or something like that for it to get accepted. And classify free guidance in diffusion models. It's in Europe's workshop paper.
Yeah.
Many people say, well, you need a conference paper. No, like this thing, everybody uses it. It's standard. It's impactful. And if somebody will look at your CV and say, you have done classify free guidance, they won't say, well, why isn't it published at a conference? They will say, hey, damn, amazing work. You really changed the field. So once you optimize for that kind of stuff, I think rejections don't hit as hard, but honestly, they still hit hard when they come. I mean, it's not like I'm saying this now and then I submit a paper and then it gets rejected I'll be disappointed for a day or two. But then like I try to remind myself of these things and then it becomes better again quite quickly.
Okay. So thank you for sharing your mindset. I think that is very helpful to others. So let's go back maybe for the CVPR paper that you joined. I mean, this work was kind of led by Nick.
Yeah.
The title is Clean Deep. So you are kind of as an observer and also sharing first author. So can you sharing us, for example, how did you guys find those ideas? And the second is in general, how you guys to, for example, discover an idea and try to make it work and try to make it submittable to conference?
Yeah, so in that case, this is one of a few papers that I've been involved in, where it's been a lot about us trying to just understand what's going on with diffusion models, with their features, with what they've been doing, with how we can control them, with how we can influence, with how we can derive features from them. And the fact that diffusion models create features that are nice for downstream use cases had been known before, right? We had we had Dift, we had the Tale of Two Features, we had diffusion hyper features, and a bunch of other works that already had explored this. And one thing they had found is that, first of all, the time step you use, so effectively the level of noise in the image, and you need to feed noisy images to the model, really determines the usefulness of the features. And that you need to do stuff like averaging them over multiple noises that you've drawn at the same level.
That is how Frank's paper doing,
How Frank's paper does it, how Diff does it, how other papers do it. That's of course suboptimal, right? First of all, having this hyperparameter that we need to analyze. Then secondly, this is like Stable Diffusion 1.5 is I think an 800 million parameter model. Now we do 8 forward passes to get some features. And when you compare this to Dino or something like that, Dino V2, it's a 100 million parameter vision transformer that we do 1 forward pass for. So we have an 8 times bigger model, now we're doing 8 or 16 forward passes. That's just incredibly inefficient. So what inspired the paper in the end was just us asking the question, or primarily Nick asking the question in that case, well, what if you can get rid of that? What if we can make the model view the world in a non-noisy way? We add noise to the images, that's obviously suboptimal. And what if we can get rid of the time step selection process? And then we came up with this whole approach to basically just fine-tune the model to get rid of these constraints, because after initial experiments of just passing clean images to it or doing other things, it just didn't work sufficiently well. And we also, funnily enough, found that you can just linearly decompose the features of a diffusion model, these diffusion features, into a part that's the same as when you encode a clean image at time step 1, into a part that's the same as when you encode the pure noise at time step 999, and some other part, which is the part that makes these diffusion features typically work better at higher noise levels. But like it's linearly decomposable into, amongst other things, the noise, which is kind of funny, right? So that also means that we can just remove that intelligently, right? Like Dift already does that by averaging over multiple inference steps. But what if we just align the features of the model to those noisy features? So we pass a clean image to the model, and then we train it to predict just the noisy features, basically, but at some specific time step. And it obviously cannot predict the noise. It does not know what the noise is. So it tries to only predict the rest. And by just doing this, and then also addressing the fact that we have different representations at different time steps, by just putting a projection layer at the end that's conditioned on the time, such that we can change the features slightly according to the time step that we're looking at. That was enough to just fine-tune the model to produce these kinds of clean features that don't have any noise anymore and that consolidate the interesting information.
Then actually there's another hyperparameter is the nail number. How did you guys choose that nail number? Is that important?
It is important. We just followed the convention of just choosing one specific layer in the case of Dift. In the case of Tale of Two Features, if you do supervised semantic correspondence or stuff like that, you might combine multiple ones. We generally just followed the convention of what people had with your question about how we made it into a paper and how we evaluated it. The main thing we tried to do was we tried to look at a bunch of applications of diffusion features and figure out how they evaluated it, and basically just show that our features are like our improvement, our fine-tuning process to make these features clean. It's just a plug-and-play thing. We can put it on Dift, and we showed an improvement with Dift. We showed an improvement with Tale of Two Features, showed an improvement with other semantic correspondence methods, which are like the standard evaluation thing. We showed an improvement on depth estimation. We showed an improvement on semantic correspondence. And just by showing that it works everywhere, it's a quite thorough and coherent thing in the end. And it's just like the paper in the end is fairly simple, but these kinds of simple papers are often also ones where if you do the evaluation right, they're really cool.
Then let's go back to the original topic. So of course, clean diff is not the only attempt that you try for your CPR submission. So can you tell us or sharing us the opinion or experience how you decide when to give up an idea, when to proceed an idea?
So it depends on. So my research style is basically with two branches. For one branch, I try to follow more long-term goals. I have some kind of vision in mind and I want to work towards that.
Yeah.
And if I have some ideas there, I will not give up as easily. And then I also have these things where I just try to understand better how these models work, how we can influence them. And I just try to do lots of experiments there. And those either, like I try to come up with theories that go against mainstream understanding of these models, try to test them. A lot of the time they're invalid. Like I just prove to myself that what people typically assume is correct is the correct thing.
Yeah.
But sometimes I find, hey, this goes against the common understanding. And then I can try to build on top of that into an idea. Or I just find some kind of weakness, flaw, or whatever you want to call it in the current understanding. And then I can expand on that. And for those things, I typically iterate through them quite quickly. Because either your thought about how things could be or should be or are will turn out to be true, or it turns out to be false, or it turns out to be incomplete. But at that point, unless you have like a reason to pursue that goal, I typically just try to figure out new things and just build my whole understanding. Mostly like a learning experience, and sometimes on the side I just discover, hey, this is cool. I could turn that into a paper. And then I have like these two branches, and that really influences things.
Okay, let's go to another topic. So can you kind of introduce one or two papers that you are most like, sharing the reason why?
So I think I'll talk about one in specific, but like in general, I'm a huge fan of the papers by the NVIDIA Finland group with Tero Karas, Mika Itala, and all the other guys, whose names I'm probably pronouncing wrong as well. And the paper I like the most, even though it's not about diffusion models, is the Algan 3 or 83 GANs. And I really love it because it demonstrates like a bunch of things. So first of all, the main thought of it is simple. And secondly, it takes knowledge that is readily available in another field, another space, in like signal processing, and shows how we can use it to address problems that we have observed in our field, in generative computer vision. Yeah, so generally like this whole thing, it's like a nice isolated thing. And also I'm personally biased. So I did my master's in signal processing. Yeah. And then them applying signal processing stuff, this had always bothered me. Like people doing this incorrectly. And then doing nonlinearities incorrectly, resulting in aliasing, and they just solved that. Yeah. And I also recently actually saw a paper doing this for diffusion units. And I always wanted to do that. But it was really nice seeing that somebody has done that. It was like 2 weeks ago or something like that.
It seems you're very interested in unit structure.
Not necessarily. I'm biggest with respect to architectures. I mean, units just have for a long time been the de facto standard. Okay. And if you do signal processing, like if you want to do something that's inspired by signal processing, convolutions are a lot nicer to deal with than self-attention.
Okay, thank you for joining my interview.
Yeah, thanks for having me again.
Yeah.
It's been a pleasure.